All right, welcome class. This is 1-2, multiplying and dividing monomials. I will try my best not to sound like a sad robot, but no promises. All right, the learning intentions today is we are going to be able to use the product of powers and quotient of powers rules to simplify expressions. Let's get to it. All right, the first thing we're going to talk about in this section is going to be the product of powers rule. That's when we are multiplying similar bases with exponents. And what I mean by similar bases is x to the second power times x to the third power. 4 to the fourth power times 4 to the third power, right? The bases are the same. And when the bases are the same, you simply just add the exponents together. All right, so what that looks like here is if we have base a with exponent m times base a with the exponent n, we get a to the exponent m plus n. Now, if that sounds like a lot of gibberish, we are going to take a look at an example here with algebraic terms. All right, so in this example, we have x squared, x to the second power, x to the second power, times x cubed, which is x to the third power. All right, now to simplify this, we are just going to use that product of powers rule, and we are going to add our exponents. So this is going to be x to the 2 plus 3, which simplifies to x to the fifth power. And that's all there is to that. All right, you can also use the product of powers rules on negative exponents, right? You can add negative exponents and positive exponents together, just like you can add negative numbers and positive numbers together. So let's see what that looks like in this example. We have y to the negative 6th power times y to the third power. All right, and what that's going to equal is y to the negative 6 plus 3, which will equal y to the negative 3, which, if you remember what we did in 1-1, to make a negative exponent positive, you simply take that inverse, right? So we're going to drop y to the negative 3 from the numerator down to the denominator, and that becomes a positive exponent, and we are left with the answer 1 over y cubed. All right, so the second thing we need to know for this section is the quotient of powers rule. That's when we are dividing similar bases, right? So 7 to the third power over 7 to the second power, similar bases. And when we have similar bases that we are dividing, we just simply subtract the exponents. And we can see that here in the algebraic formula, right? A to the m power divided by a to the n power equals a to the m minus n. And once again, we're going to take a look at some examples and see what that looks like in practice. All right, here in this example, we have 5 to the 7th power, 5 to the 7th, divided by 5 to the 4th power. Now, based on the quotient of powers rule, that is just going to simplify to 5 to the 7 minus 4th power, which simplifies 7 minus 4 is 3, so that equals 5 to the third power, or 5 cubed. And if and only if you are asked to evaluate, actually crunch the numbers, and that would equal 125. All right, and that actually did it for section 1-2, multiplying and dividing monomials. So once again, if you would like some extra credit, write and solve a problem involving multiplying and dividing monomials. So for extra credit this time, you will need 2 problems. All right, second part of this video is going to cover our work for Thursday, 1-3, multiplying linear expressions, all right? The learning intentions at this point is going to be able to use that distributive property. Hopefully you guys remember that. And the product of powers rule that we just learned earlier in the video to multiply linear expressions. I know that's a lot of just words to you right now, but hopefully by the time we're done with this video, it'll be a little more clear. All right, the really nice thing about this section is it's not anything new. It's 7th grade standards of distribution mixed with some stuff we learned earlier in this video, the product of powers, right? So the first thing we need to learn and make sure we understand when it comes to multiplying linear expressions is that you know the distributive property, all right? The distributive property says if we have x multiplied by a plus b, that is the same as x times a plus x times b. And once again, we're going to see some examples here once I'm done with the definitions. All right, and on the off chance that you have already forgotten the product of powers rule from earlier in the video and you don't want to rewind it, because I get it, that's a lot of work, here it is for you again. A to the m power times a to the n power equals a to the m plus n power. All right, let's keep both of these things in our mind while we do these examples. All right, for this first example, we're going to keep it really simple. We're only going to use that distributive property, right? So we're going to have 3 times x plus 3. 3 times x plus 3. Now we're going to use the distributive property to understand that that is the same thing as 3 times x plus 3 times 3. And if we simplify those two, we get 3x plus 9. And that is our final simplified answer when we multiply out, distribute 3 times x plus 3. All right? Next example is going to include some algebraic terms, and we're going to see that product of powers rule come into play. All right, so here's our final example. We have 4x times 2x plus 3, right? So we're going to distribute that 4x to each term, to 2x and to the 3, and then we're going to use that product of power rules to simplify. All right, here you can see we have used the distributive property now to distribute out the 4x to each term. So we have 4x times 2x plus 4x times 3. Now we're going to just simplify those. And when we simplify this first term here, that 4x times 2x, you're going to have to use the product of powers rule. Let's see what that looks like. All right, and your final simplified answer is going to be 8x squared plus 12x. And let's go over how we got that, right? Let's go back a step. So we got the 8 and the x squared from our first terms here, right? 4 times 2 is 8, and x to the first power, that's x to the 1, times x to the 1. Well, that's 1 plus 1, so that's x to the 2. And in our second term, we have 4 times 3 gives us 12, and x is all by its lonesome here, so it's all by itself in the answer. All right, that's all there is to it. So once again, if you'd like a little bit of extra credit, please feel free to write and solve your own problem based on what you have learned here in the notes for 1-3. Have fun. Hope you enjoyed it. Probably didn't because it's notes, but hey, it's not that bad.